गुड इवनिंग स्टूडेंट्स। लास्ट क्लास में हमने फर्स्ट ऑर्डर रिएक्शन के लिए देखा था। आज हम बात करने वाले हैं सेकंड ऑर्डर रिएक्शन के बारे में। तो देखिए, सेकंड ऑर्डर के लिए वही वाली बात है कि हमें सबसे पहले उसका वेग अवकलित समीकरण निकालना पड़ेगा। इसकी वेग जो अवकलित समीकरण है वो कैसे निकालेंगे, ये देखने वाली बात होगी। तो आपको सबको पता है कि जो रिएक्टेंट्स होते हैं वो किस में कन्वर्ट होते हैं, प्रोडक्ट में कन्वर्ट होते हैं। जब रिएक्शन स्टार्ट नहीं होती तो उसकी इनिशियल कंसंट्रेशन ई मानेंगे, प्रोडक्ट की कंसंट्रेशन ज़ीरो होगी। आफ्टर सम टाइम, मतलब टी टाइम्स, वी कैन से दैट 5 minutes, 10 minutes, 20 minutes, the x mole of reactant will convert into product. So we can say the remaining concentration of reactant will be E minus x, and the concentration of product will be x. And at if t is equal to t half, meaning if the time which is required for consuming half concentration of reactant into products, then that will be called the half life of this reactions. Then we can say the x is equal to a by 2, meaning the concentration of product is equal to a by 2. So we can say that the uh, concentration of reactant is a by 2 and product concentration is also a by 2. So that is the basically the symbolic representations of any kind of reactions. And we will talking about the rate differential equation for second order reactions. So we will start from the rate law of this equation. So what is the rate law? रेट लो इसके लिए क्या होगा, देखिए। रेट लो के लिए अपन बात करते हैं कंसंट्रेशन ऑफ प्रोडक्ट डिवाइडेड बाय टाइम, इट इज इक्वल टू रेट, एंड यू नो रेट इज इक्वल टू रेट कांस्टेंट एंड द कंसंट्रेशन ऑफ रिएक्टेंट की पावर n. Okay, then the concentration of product at t time will be the concentration of product at the t time will be, you know very well that the concentration of product is equal to dx upon dt. Okay, it's no problem. Then equal to k, and the remaining concentration of reactant at time t is equal to e minus x, and the power is the order of reaction. So you know very well that the power to power, so the order of reaction will be second order reactions. So second order reactions. Okay. So you know the dx, the differentiation with respect to x. So we will write here 1 upon e minus x dx is equal to k dt. Okay, and then this is the integration of this equation, because it is the differential equations, and the final summation of this equation, or we can say the final result of this equation is can be get we can get from इंटीग्रेशन, समाकलन इसको कहते हैं. तो हम इसका समाकलन यहाँ पे करेंगे इस तरीके से. The integration of this 1 upon e minus x square is equal to 1 upon e minus x, and because the k is the constant quantity, so there is no possibility of integration of k, so k is remaining here as such, and the integration of dt is equal to t. So we can say the another integration constant will be present here, so we can say the equation is 1 upon a minus x is equal to kt plus c. Okay, there is no problem. Then so we can say again right here 1 upon a minus x is equal to kt plus c. 1 upon a minus x is equal to kt plus c. Then we will talking about the what is a c. What is a c? Because there is a no meaning of c, because you know there is a one meaning is the one is a numerical value, and a is the initial concentration of reactant, and x is the concentration of product at t time, and k is the rate constant, t is the time. But what is a c? There is no meaning of c here, because it is a simple mathematical constant. So we will put the value of c in terms of chemical kinetics, or in terms of c a x k t. So for changing the c into another symbol, or we can say another considerable value, we will find out the value of cy, considering if t is equal to 0, meaning we will talking about the initial stage of this equation, which is t is equal to 0. T is equal to 0 means and the situation of reaction, or we can say the condition of reaction at time 0, time is equal to 0. So the x is equal to also 0 meaning the concentration of product will be 0. So we can see here that this is the view of this equation. When t is equal to 0, then x is equal to 0, you can say see here. So 1 upon a, because x is equal to 0, so 1 upon a k into 0, because time is also 0, plus c. So we can say c is equal to 1 upon a. C is equal to 1 upon a. Then put the value of c into equation number 1. Put the value c into equation number 1. So 1 upon a minus x is equal to kt plus 1 upon a. Okay, this is the equation number 2. This is the equation number 2. Then we can rearrange this equation into this term, that we'll again write here 1 upon a minus x is equal to kt plus 1 upon a. Rearrange this equation. One upon a minus 1 upon a is equal to kt. Okay, then we'll take the LCM of this equation. A minus x, then 1 minus sorry, the LCM of this equation is a into a minus x, then cancel out a minus x from a minus x, then remaining is a minus x is equal to kt. Then a cancel out from a, and minus minus plus, then the final equation is x a minus x is equal to kt. Okay, then this is the final equation, where we can say that we can make if we can calculate the value of k from k is equal to 1 upon t x a minus x. Okay, this is the value of k, or we can say t is equal to 1 upon k x upon a minus x. Here t is equal to time, k is equal to rate constant, x is equal to concentration of product, a is equal to initial concentration. Okay, this is the all about the rate differential equation for second order reactions. And another thing will be the half-life of the reaction. Of second order reaction. One equation is this: T is equal to 1 upon K x upon A into A minus x. And for simplifications, we can say that uh, 1 upon A minus x minus 1 upon A 1 upon 1 upon K is equal to T. Then if T is equal to T half, then x is equal to A by 2. Okay, put these condition in above equation. Put these conditions in above equation. One A minus A by 2 minus 1 by A 1 upon K is equal to T half. So 1 minus A when A by 2 is subtracted from A, then remaining is a 1 upon A by 2 minus 1 upon A 1 upon K is equal to T half. Then there is a 2 by A minus 1 by A 1 by K is equal to T half. The remaining is 2 by when 1 by A is subtracted from 2 by A, then remaining is 1 by A 1 upon K is equal to T half. So we can say that T half is equal to 1 upon AK. So there is a clearly indicate that the T half is inversely proportional to A, meaning if the concentration of initial concentration of reactant will be increased, then T half will be decreases, because the rate of the reaction is directly proportional to the concentration of reactant twicely. So because there is a power of 2, so when we increase the initial concentration of reactant, then there is a there there is an exponential increment will be takes place in the rate of reaction. So there is a reaction will be speed up, and there is a minimum time will be required for the 50% completion of this equation. So we can say there is a T half is inversely proportional to initial concentration of reactant, and there is a major difference in between zero order, first order as well as second order reactions. So we can say we can get a comparison between first, second, third. There is a zero order reaction, first order, and second order. First order T half is directly proportional to A. In first order reaction, T half does not depend on A or independent from A, and second order reaction T half is inversely proportional to A. So there is a major difference in between zero, first and second order reactions. So these are the three different type of reactions in which we can calculate the time as well as rate constant of these equations. Thank you.